When does physics begin? There seem to be two popular places to start. Either with the scientific revolution, with Copernicus, Galileo, Kepler, and Newton, or much earlier, with the Greek philosopher Aristotle. Because to trace the line of thought that led to Copernicus, you absolutely must pass through the early Greek philosophers. And this is where I'll begin. That story begins with the collapse of 1100 BC. Before that time, the Mycenaean civilization covered what's now Greece and parts of western Turkey. It was a powerful and important civilization, with its own religion, language, and culture. The point, though, is that sometime around 1100 BC, it just collapsed. We don't know why. Maybe it was Dorian invaders or mysterious sea people. Maybe it was climate change or earthquakes. Maybe internal social conflicts. Whatever it was big, and it wasn't just them. It was a general Bronze Age collapse across the Mediterranean. It was seen in the Hittite Empire, the Egyptian Empire. Something happened, and it sent Greece spiraling into a long dark age. Greece descended from large palaces down to isolated villages. Whereas before communication between cities was easy, now just traveling to a nearby town was dangerous with the old political order destroyed. The written language was lost. The religion was lost. For 400 years, Greece slept in this dark age, and when it awoke from its slumber, it entered one of the most celebrated periods of art, mathematics, and science in history. Which brings us to roughly 600 BC in Ionia, located on what is today the western coast of Turkey. It's here the curious miracle happened. People began asking questions and inventing answers. These philosophers weren't afraid to question the traditions that were handed down to them. It's not clear exactly why this miracle happened at this time in this place. The early Ionians were, to a large extent, colonists. Perhaps these Ionian settlers found themselves in a new political climate with new freedoms. Pioneers are often adventurous, resourceful, and original problem solvers. Or perhaps it was geographic. Greek, Phoenician, and Egyptian ships mingled in Ionian harbors, and Anatolian caravan roads led from Ionia to the whole of Asia. Wherever large groups of people of different cultures, backgrounds, and traditions meet, the most intelligent among them begin wondering if their own traditional answers are the right ones. They begin questioning assumptions they never realized they had made. Ask anyone who's traveled a large distance to move to a big city with a diverse population about how the experience has opened their eyes to new possibilities. In any event, it's here that Greek philosophy began. Tradition holds that there were 7 wise men of Greece. Now, good things always happen in sevens, so everyone can agree that there were 7, but they can't seem to agree on who those wise men were. But at the top of almost everyone's list was Thales of Miletus, the first Greek philosopher. Funnily enough, his name is on the list for something that it's likely he never did. But it's one of those stories that has become so widespread that we're forced to retell it, if only to explain that it's dubious. The legend says that once upon a time the Lydians, who lived just east of Ionia, were at war with the Persians, who were the perennial enemies of Greece. They'd been at war for a long time, with ups and downs on both sides. Then one fine day, which we now know to be precisely May 28, 585 BC, the Lydians and the Persians went out for battle, and just as the fight had begun, the day suddenly turned to night. And this, the legend goes, was foretold by Thales. The two sides were so struck by the eclipse that they immediately brokered a peace agreement. For a while the theory was that Thales had picked up on some patterns in Babylonian eclipse data and was able to hazard a guess. Nowadays, scholars don't believe that Babylonians could possibly have had the data Thales would have needed to pick up on any patterns, so it's most likely he was just the smart guy who happened to be around when the eclipse occurred, and the Greeks embellished as they often do. So now that that's out of the way, I want to tell a more modest story. Thales was born sometime around 624 BC in Miletus, the main harbor and richest market of Ionia. With all the bustle of Miletus, there was much to learn, but Thales wanted to know everything that he could. And the only way to do that, he figured, was to go to Egypt, the source of all ancient wisdom. There he learned mathematics and astronomy. Keep in mind that in those days, mathematics was mostly geometry and some algebra, and astronomy was basically just noticing where and when the stars and planets appear. And both topics were wrapped up with religion and mysticism. But Thales was apparently a practical man. Frankly, we don't know much of his life, but we do have some examples of his cleverness and pragmatism. For example, he was able to measure the height of the Egyptian pyramids by looking at their shadows. When you stand outside and watch your shadow, you notice it's long in the morning and evening and short at noon. According to legend, Thales waited until his shadow was as long as he was tall. Then he reasoned that the same would be true of the pyramid at that moment. He measured the length of the pyramid's shadow and reckoned it would be as long as the pyramid's height. And by doing so, he measured the height of the pyramid without needing to climb it. He was also able to measure the distance of a ship to the shore using a friend and some geometry. Thales imagined standing on the beach with a ship off to his side. First he placed a little blue marker where he stood. Then he paced off some arbitrary distance downshore, let's say 20 paces, and put a little red marker there. Then he paced off another 20 paces and put a little green marker there. Then he imagined drawing a line from the first blue marker to the ship and extending it. Then he drew a line through the second red marker to the ship and extended it. Finally, he drew a line through the green marker, parallel to the first line. When he was done with that, he had two triangles. And he was trained enough in geometry that he could prove mathematically what you probably already suspect from looking at this picture. The two triangles are exactly the same size, but flipped. Since the top triangle is sitting over land, he could just measure off the length of its side and be confident that it had the same length as the distance to the ship from the shore. Now this is a little more convoluted than how a modern mathematician would do it. Today we would just measure the two angles and use a branch of mathematics called trigonometry. But trigonometry hadn't been invented yet in Thales' time. Using these sorts of triangles to measure distances is so useful that we give it a name, triangulation. And later, a man named Aristarchus would use a similar technique to measure the distance to the sun. But that's a story for another day. Incidentally, Thales' interests didn't end with math and astronomy. He supposedly got rich by cornering the olive market. He was active in politics as well, attempting to organize the Ionian colonies to guard against the growing power of Persia. Ultimately, he may have lived long enough to see his fears realized, as near the end of his life, the Persians conquered Ionia. He was also known to rub shoulders with another of the 7 wise men of Greece, Solon of Athens, who planted the foundations for the world's first democracy. As I said, a lot of new ideas were floating around. Anaximander was a fellow citizen and companion of Thales. 15 years his younger, he must have received instruction from him, and we could perhaps call him Thales' student. Toward the end of his life, he wrote a book, On Nature, describing his theories of the cosmos. That book, along with anything else he might have written, has long been lost. But we can try to piece together his thoughts from the numerous references that other ancient authors made to his work. Anaximander is credited with bringing the gnomon to Greece. When put that way, it sounds more dramatic than it is. A gnomon is essentially just a stick, sitting perpendicularly in the ground, like a sundial. By looking at the length and position of its shadow, you can determine the position of the sun in the sky. Now, the gnomon was already in use in Egypt and Babylonia, and you'd assume any intelligent person would have noticed that a stick casts a shadow, and the length of the shadow depends on the position of the sun. But Anaximander gets the credit, in this case presumably because he was the first in Greece to use it systematically to study the sun. Anaximander apparently used this gnomon to construct a mechanical theory of the cosmos. If you watch a gnomon day after day, you'll notice the shadow sweeps across the land, long in the morning and evening, short at noon. But the exact details change over the course of the year. This is, of course, because the sun's path differs throughout the year. At noon during the winter, the sun is lower in the sky than at noon during the summer. The moon follows a similar path, but instead of taking a full year to repeat its journey, it takes only a month. Anaximander was able to measure this, and came up with a crude mechanical model of how the cosmos works. The Earth is held up by nothing, but remains stationary because it is equally distant from all other things. Its shape is flat, like a drum. We walk on one of its flat surfaces, while the other is on the opposite side. Up to this point, most cultures imagined that the Earth was floating on water, or supported by pillars, or some such thing. But Anaximander pictured the Earth as suspended, held up by nothing. Unfortunately, we can't ask him to explain how he believed that equidistance somehow makes the Earth stationary, or why the Earth is a cylinder, in this case, and not a sphere. But regardless, the idea that the Earth doesn't need to be held up by anything has been called one of the most revolutionary ideas in the history of human thought. According to Anaximander, around the Earth we have a wheel that contains the sun. The sun is a fire, enclosed on all sides by its wheel. We see the sun because there's a little window on the side of the wheel. This window can close, causing an eclipse. The moon is similarly enclosed by its wheel, but its window opens and closes much more frequently. The wheels rotate around the Earth, and the sun wheel slides up and down throughout the year to explain the solstice and equinox. The moon wheel has a similar motion. Notice that the sun and moon all travel beneath the Earth. They don't just sink into the sea or some such thing. They simply continue traveling along their circular paths. And this is possible, of course, because the Earth has no supports to get in the way. This model seems a little clunky to us, but it's the first mechanical model of the cosmos that I know of, and it does a decent job of accounting for the paths of the sun and the moon. However, it doesn't have much to say about the timing of eclipses, and has nothing to say about the motions of the planets. But for all its shortcomings, Anaximander's model, with the Earth suspended with no supports, and with the sun, moon, and stars circling it, was the baseline. It paved the way for future models which were better and increasingly complex. If legend can be trusted, and it frequently can't, then late in his life, Thales had a young student by the name of Pythagoras. Yes, that Pythagoras, of Pythagorean theorem fame. Pythagoras lived in a time when oral history was just giving way to written history. It doesn't help that he insisted that his teachings not be written down, and his followers sworn to secrecy. By the time people got around to writing his story down, he was already viewed as a saint, a miracle worker. Miracles, implausibilities, and contradictions appear at every corner of his story. In short, you can't trust anything I'm about to tell you. Pythagoras was born in Samos, an island off the coast of Ionia, which was then ruled by the tyrant Polycrates. He reportedly fled Samos to escape Polycrates' tyranny and ended up in Miletus, where he met Thales, who was so impressed with the man that he taught Pythagoras as much as he could. Following Thales' example, Pythagoras decided to travel to increase his knowledge. He sailed to Phoenicia, then to Egypt, where he spent 22 years studying astronomy and geometry, as well as the mysteries. In 525, the Persians conquered Egypt, and Pythagoras was carried captive back to Babylon and studied with the Magi, who were the priests. By his 50s, he finally settled down in the Greek colony of Croton, which is now in southern Italy, and began his famous school, where he led many followers. Indeed, it's often difficult to separate what Pythagoras did from what his followers, the Pythagoreans, did. In some ways, Pythagoras could not have been more different from Thales. Where Thales had learned from the Egyptians and tossed out much of the magic and mysticism, the Pythagoreans were obsessed with the mystical power of numbers. Numbers are the essence of things. They believed the sphere was the most perfect shape, and uniform motion, in other words, not speeding up or slowing down, was the perfect form of motion. The Babylonians had been content to simply record as accurately as possible the movements of the planets, but the Pythagoreans wanted to explain them. The planets must have motion that is circular and uniform. Are they not perfect celestial beings? How could it be otherwise? The problem, of course, is that they don't seem to move exactly with the other stars. So the Pythagoreans believed that they must move in a perfect uniform circle of their own, in the opposite direction of the rest of the stars. I don't think they got too specific about this. They were just sure that if they could somehow analyze those complicated motions properly, you'd see it was all just perfect uniform circles. But notice, this was all motivated by a more or less arbitrary mystical conviction that circles are perfect.